Hello James, welcome to episode 3 of Workcuts. In this video, we are going to discuss about digital math. So if you're somebody like me who screws up calculations, messes up with calculations, this video is going to be a bliss to you, okay? By the end of this video, you will be able to solve questions like this by yourself under 30 seconds. So with that being said, let's begin. So the first thing that we need to know in digital math is digital sum, okay? Digital sum. Okay, digital sum, as the name suggests, it's the sum of the digits in a number. Digital sum is the sum of the digits in a number. Another definition is there which says it is the remainder obtained when you divide a number by 9. Okay, both the definitions are actually mathematically equivalent, so you can actually prove that, but we are going to focus on the first definition. Okay, we are going to keep that second definition aside. We are just going to say that digital sum is the sum of the digits in a number. Okay, let's take an example. Suppose 1 2 3 4. Tell me its digital sum. Okay, what are you going to do? Either you can divide by 9, report me its remainder, or you can add the digits. Let's add the digits. 4 plus 3 7, 7 plus 2 9, 9 plus 1 10. Okay, you have to now repeat the process until you get a single digit number, right? It will be a remainder of 9, so it should be a single digit number. Anyways, let's come over here. So 10. 10, again repeat the process. 1 plus 0, right? Add the digits. 1 plus 0 1. Okay, so the digital sum of this number is 1. Okay, now let's go for one more number. 7 8 4 1. Now tell me its digital sum. 7 plus 8 15, 15 plus 4 is 19, 19 plus 1 20. Okay, 20. Again repeat the process. 2 plus 0 2. Okay, now this were two very small numbers. Let's take a very big one. 9 8 4 1 3 2 6. Okay, now tell me the digital sum of this number. Now if you go to do it like this, it will be a lengthy thing, right? It would be calculations and calculations, something which we are not supposed to do today, right? So come over here. Okay, come over here. I have something to tell you. Okay, so 92, 93, 94 and 95. Tell me the digital sum of each of this number. Okay, 91, 92, 93, 94, 95, and finally you can go for 90 and 99. Okay, so let's do it. Okay, 9 plus 1 10. Okay, repeat the process. 1, here we have 11. 9 plus 2 11, and 11, repeat the process. 1 plus 1 2. So can you note the pattern? Can you note the pattern? Here you will see that 91 is 1, 92 is 2, 93 is 3. So the fact is that you can just ignore that 9. Okay, you can just ignore that 9. That is the idea we are going to use over here. Okay, not just 9, you can ignore any number that adds up to 9. Right, here you can ignore 9, 9, 9, 9. The digital sum remains the same. 1, 2, 3, 4. Okay, 5. Yeah. Not just 9, you can ignore any number. Okay, any number that adds up to 9. For example, suppose 5 4 2 you have. 5 plus 4 9. You can ignore both these numbers. Okay, any numbers that add up to 9, you can ignore them, just like 4 4 1 and 3. Suppose 4 4 is 8, 8 plus 1 9, so you can ignore all these three numbers. Okay, the digital sum will be 3, so you can ignore 9 and numbers that add up to 9. Okay, so that is the idea that we are going to use over here. And what about that now? What about that? So if you go by the definition, what will be the digital sum of 90? What will be the digital sum of 90? 9 plus 0, right? 9. Okay, 9. And if you go by this idea, ignore 9. You'll just cancel that 9. The digital sum is 0. Okay, so which one's right? Actually both. Okay, actually both, because in digital maths 9 and 0 are equivalent. Okay, 9 and 0 are equivalent, so pick up that idea. Okay, 9 and 0 are equivalent. Here also you will see that 99, so either you can say it as 9, the digital sum is 9, or you can ignore both the 9s and you can say that the digital sum is 0. 0 and 9 are equal in terms of digital maths. Okay, let's come over here and do this problem now. Find the digital sum of this biggie now. Okay, so 9 goes, 81 goes, 81 goes, 6 3 goes, and okay, Here we can see that 4 plus 3 is 7, 7 plus 2 9, so this you can cancel. Now you are left with 2 fours 8, 8 and 2 is 10, 10 means 1, 1 plus 2 is 3, so that is digitally 3. Okay, so now we know about digital sums, but how to use that in our questions. Okay, so the only thing that we are going to use actually is digital sum on the left hand side equals digital sum on the right hand side, or digital sum of the question equals digital sum of the answer. Okay, let's take a simple addition case. Suppose 28 plus 35, suppose. Okay, 5 plus 3 13, and okay, 63. Then you can find, you can prove this. Okay, digital sum on the left hand side equals digital sum on the right hand side. Here you will get 10, 10 means 1, 5 3 8 and 6 3 9, right? So you verified that, right? 8 plus 1 9. Okay, so the digital sum on the left hand side equals digital sum on the right hand side. Now this was for addition, so you are getting the idea, right? What we are going to do, we are going to find the digital sum of the question, find the digital sum of the options, and then just match the things. Okay, that is the thing. Okay, we are going to avoid calculations completely. That's why I named it no more calculations. Okay, now let's go for multiplication. Multiplication also the similar case. For subtraction also the similar case. Division will come to it. Okay, let's go for multiplication first. So 11 into, suppose let's take 22. Okay, 11 into 22, anything you can take, so you will get 242. Now verify that. Here you will get 2, 1 plus 1 is 2, into 2 plus 2 is 4. Here 2, 2 to 4, 4 plus 4 8, right? So 8, and here 2 4s are 8. So the digital sum on the left hand side equals digital sum on the right hand side. This is something that we are going to use in the question. Okay, now just write the table of 9. Okay, write the table of 9. We are going to note something interesting over here. So let's begin. 9 1s are 9, 9 2s are 18, 9 3s are 27, 9 4s are 36, 9 5s are 45. Okay, I'll write it till here. Now find the digital sum of each of the products. Find the digital sum of each of the products. 9 is 9. Okay, 8 plus 1 9, 2 plus 7 9, 3 plus 6 9, 4 plus 5 9, 5 plus 4 9, 6 plus 3 9, 9 9 9 9. Okay, so can I say it in a general way that 9 into anything, any number, is will give us digitally 9. Okay, so 9 into anything is digitally, the digital sum of that number will be 9. 9 if a number is of this form, 9 into anything. So if a number is of the form 9 into anything, the digital sum of that number will be 9. So you can actually verify this by the second definition. The second definition says that the digital sum is the remainder when you divide the number by 9. So if the number is of this form, right, 9 into anything, and you divide it by 9, okay, 9 and 9 will get cancelled, or 9 or the remainder will be 0, because this number is of course divisible by 9, right? So the remainder will be 0, or the equivalently you can say 0, right? Digitally 0 means 9, right? So this comes from that idea. So in addition, 9 doesn't make any difference. You can ignore 9 in addition. In multiplication, 9 makes everything 9. Okay, so wherever you spot a 9, just in multiplication it will make everything 9. Okay, so remember these two facts. So this thing, and in addition you can ignore 9. In multiplication, 9 makes everything 9. So let's go for problems now. Okay, so here are 4 questions on the board which we are going to shatter digitally. Okay, so of course you can add this and spend time doing it, but we are going to do it digitally. Let's do it. So 5 4 9, 8 plus 3 11, 11 means 2. Here we have 2 and 7, 9, that is 9, so I remove that. 2 plus 3 5. Here we have 6 plus 1 plus 2, which is 3. We are left with 4. 6 plus 3 9, and here we are left with 3. So 7 plus 7, 7 plus 7 is 14. 14 means 1 plus 4 5. Okay, so the digital sum of the question is 5. Now let's check for the digital sum of each of the options, and we'll match one of them to the question. So that will be our answer, of course, naturally. So let's do it. So I can do is 6 1 1, so that is 8, and one more 1 I'll borrow from here. I'll split that 4 into, I'll create 9, okay, you can also do that. So 4 I'll split it into 1 plus 3. So okay, so this one goes and we are left with 3. Option 1 has digital sum 3, it is not the correct one. So 6 plus 2 8, 1 3, and here we'll have 4, so digital sum 4. Here 6 3 gone, 1 plus 4 5, so this may be the answer. Let's go for this one. 6 plus 3 9 gone, and this has digital sum 6, which is not the desired one. We want 5, so C is our answer. Okay, let's come over here. You can see that 7 plus 7 plus 7 14, 14 is 5, 5 and 4 is 9, so this is 9, right? So 9 into anything, 9 into anything is 9, right? We need not calculate the digital sum of that, it will be finally 9 only. Okay, so 9, so we have 9 over here. Now let's do it. 6 3 gone, 8 3 is 11, 11 means 2. Okay, here we have 6 3 gone, 2 plus 1 3, 6 3 gone, 2 plus 8 10, 10 and 10 means 1, and finally this will be the 1. Okay, so this is 10. If you see, 10 means 1, and 1 plus this 6, 6 plus 2 plus 1 is 9, right? 6 plus 2 plus 1 is 9. Okay, so this is the correct option, D. Okay, let's come for this one now. This one, 5 4 gone, 6 3 gone, 1 2 is 3, so 3 into 11, 3 into 2 you can say, right? 11 is 1 plus 1 2. Here what do we have? 1 plus 2 plus 3 5, 6 plus 5, 4 plus 1 5, and 9 plus 2, we can just ignore that, 9 2, right? So this is into, now we have 3 into 2, which is 6, plus here you will get 11 into 2, 11 into 2 is 22, 22 2 2 plus 22 is 2 plus 2, which is 4, so 4, and here you will have 10, 10 means 1, right? 10 means 1 digitally. So we want 1, so let's do it. So 5 plus 4 9, 8 plus 3 11, and 2, 11 is 2. So 5 plus 4 9, this is 10, and 10 means 1, so this may be the correct one. So let's check the other one. 5 plus 4 9, 9, and here we have 9, so we don't want that. 5 plus 4 9, and 4 plus 8 is 12, 12 means 3. Okay, 12 means 3, so the correct one is B. Okay, let's come to this one and see what is the special thing it has to say. Let's do it. 6 3 gone, 5 6 11, 11 means 2. Okay, here we can have 5 plus 5 10, 10, and this 2 plus 2 is 4, 4 plus 1 is 5, right? 5 plus 5 10, 10 means 1, 1 and this 2, 1 and this 4 is 5, so 5 2s are 10, 10 means again 1. Okay, so we want the option with digital sum 1. Okay, let's do it. 4 4 is 8, and this is 1 9, so everywhere you can remove that. Now coming here, 9 is gone, 6 3 is gone, 5 plus 7 is 12, 12 is 3, right? 12 is 3, 2 plus 1 3, 5 plus 4 gone, 9 gone, 7 3 10, 10 means 1, 5. Okay, now 9 is gone. I can do one thing, I can break this 2 plus 3, 5 is 2 plus 3, and this is gone, 7 2 gone, 3 6 3 gone, right? Wow, and this is 1. So we have two options with 1. Digital sum of two options is 1. So what to do now? Let's do this one first. So 9 gone, 7 2 gone, 5 6 11, 11 means 2. So these two for sure are not the choice, not our answers. Now what about this 2? Now this is a very kiddie thing, and don't fake that you have noticed it. Okay, now I will tell you and you laugh. Okay, it is 3 into 2 6, right? 3 2s are, always try to multiply the unit digit, right? That is the most basic thing. If you didn't know digital maths, that was something which you would rely on, right? 3 2s are 6. Keep your mind open. So here we have 3, right? This, I would have neglected this option at very first. Okay, so that should be the thing. 3 2s are 6. So 6 6 6 everywhere except this one. So this is obviously wrong, right? So this is the correct one. Okay, let's go to the second round of questions now. Digital sum can be also used to solve questions wherein you have percentages, also where you have decimal points. Okay, digital sum is not influenced by their presence because you can see that 23%. What does that mean? 23% means 23 upon 100, right? What is the digital sum of 100? Now you can break this digitally. This will be 5, and at the bottom 100. So 100 digital sum 1. Any power of 10 digital sum is 1. So yeah, 1 in the denominator. How will that influence, right? So digital sum also works on questions having percentages and decimal point. Decimal also the same thing, right? 2.314 can be written as 2314 upon 123, right? So in the same manner, here also you can see that digitally the denominator is 1. So how will that influence? Okay, that won't have any effect on our digital sum. Okay, so we can proceed by the way we want to, our way of digital maths. Okay, so let's do it. Let's not speak much of it. So here we have 5. Okay, 23 means 5, 590 means 9. We can ignore 5, and here we'll have 3 4 7 7 and 2 9, and here we have 1 into 7 to 9 4. Okay, 4. Here we have 7 to 9. Okay, this is 9, right? This is 9, so 9 into anything is 9. So here we have 25. 25 means 7. 5 5 are 25. 25 means 7. 4 1 are 4, and 9 won't affect, so let's leave that aside. So 7 7 4 11. 11 means 2. Okay, 11 means 2. So you have to search for 2 in the option. Okay, 2 in the option. Let's do it. 7 2 goes 6. I can't find anything more. 6 3 goes. 5 4 goes. Okay, 8 2 is 10. 10 means 1 1, and this 4, 1 and 4 is 5. Okay, now I'm not so stupid to do every of those things, because see, the only digit differing is 3, right? 4 3 2 1. That's the only differing digit. So it's just decrease the number by 1. So decrease the digital sum also by 1. So here you'll get 4, here you'll get 3, here you'll get 2, and 2 is what we want. So this is the correct answer. So now let's go for division. Okay, here are the questions of division. Actually, this is the question that I displayed in the very beginning of the class, and let's do it now. Okay, so we have 3 by 4 into 23 plus 6.213. Okay, so 3 by 4, either we can divide and find the answer, right? Directly divide, and I'll give you another approach over here. For now, we'll divide. Okay, 3 by 4. 3 by 4 is 75%, so I can say it as 0.75. Okay, 0.75 into 23 plus 6.213. Okay, so let's do that digitally now. 7 plus 5 12. 12 is 3, and here 2 plus 3 5 plus 6 3 goes 2 plus 1 3. 3 5 is 15. 15 is 6. 6 plus 3 is 9. Okay, 9 or 0 we want. So 6 3 goes. 4 plus 3 7. 7 plus 2 9. So this might be the answer. Here let's come for 5 4 is 9. 3 3 6. 6 plus 2 is, okay, I can see that all the digits are same, so this will be 8, right? Decrease by 1, decrease by 1 7, decrease by 1 6. Okay, so the only correct one, the only one that has 9 is the correct one. Okay, so that is the answer. Okay, I'll clear this portion of the board for that one. That is a good one. Okay, let's do it. This 9 will go. 6 plus 6 is 12. 12 plus 1 13. 13 means 4. And in the bottom we have 4 plus 3 is 7. Okay, now this is something which is not terminating. In the previous problem we had 3 by 4, which was terminating, right? 0.75. So we could easily do it. Now we need to use some logic. This is the general way. I'm I'm going to tell you a way which is the general way to do division problems. Okay, so let's continue. So 4 4 8, 8 to 10, 10 is 1, 1 plus 1 plus 4 is 5. Okay, we get a 5 over there. 7 to 9 gone, and we are left with 2 plus here what do we get? 6 and 3 plus 1 we can remove 3, and 1 plus 1 plus 1 3, and here we have 8. Okay, 1 plus 1 plus 1 3, and plus 5 8. 4 plus 4 is 8. Okay, so here we'll get 1. 8 by 8 is 1, and here we have something absurd. Okay, now I will tell you the general way of solving such problems. So you look for this pairs. Okay, pairs, one is 2 5, second one is 4 7, and the last one is 8 8. So whenever you have this 5 in the denominator, okay, in this case you don't have it. Okay, I'll say this way, 5 2. Okay, vice versa. Okay, so whenever you have 2 in the denominator, you have to multiply and multiply numerator and denominator with 5. Okay, whenever you have 7 in the denominator, you have to multiply the numerator and the denominator with 4, and vice versa. Okay, if you have 4, you have to multiply and multiply numerator and denominator with 7. Okay, vice versa. And here you have 7, so what will you do? Multiply the numerator and the denominator with 4. Okay, so 4 into 4 upon, you'll get the logic behind this when you solve it. Okay, why we are doing this, you'll get it over here. Here we have 2 in the denominator, so we have to multiply 5, right? So we have to multiply 5 in numerator and denominator. Okay, plus 1. Now what do we get? Here 4 4s are 16. 16 is nothing but 7 7, and if you see this, 7 4s are 28. 28 is 10. 10 means 1. So that was the logic behind doing all this thing, doing that pairs. Okay, so those pairs, if you see, 2 5s are 10, so that is digitally 1. 7 4s are 28, digitally 1. 8 8s are 64, digitally 1. Okay, so that is the idea behind that. So you don't have to worry about fractions then, right? 7 by 1, you can just write it as 7. Okay, here also 5 2s are 10, so that goes off. 5 5s are 25. 25 is 7 again, right? And you'll have 1 over here. 7 7 14. 14 means 5. 5 plus 1 is 6. Okay, so we are looking for 6. So 6 6 6 6. So 6 5 11. 11 is 6 5 11. 11 is 2. 2 plus 1 3. So this is not the correct one. 16 is 7. Okay, 9 goes. This is 6. So this might be the one. And here 8 1 goes, and we are left with 5. Okay, so this is the one. Okay, this is the correct answer. So one more problem we'll discuss. That will be your homework actually. Okay. Okay, so here is your homework question, but I'll do it the halfway. I'll leave you at a crossroad. Okay, so 7 2 gone. Here we'll have 10. 10 means 1, and here also we'll have 1, right? So minus. Here what we can do, we can remove 9. 5 5 10, and 1 we have. 10 is 1, so 8 1 we can remove, that is 9. So 2 2 is 4. Okay, 4, and in the denominator we have 7, right? In the denominator we have 7. Now this is 2 minus, now multiply by 4, right? Denominator we have 7, so multiply 4 in the numerator and the denominator, so you get this thing. So that will be 1, right? 4 7s are 28. 28 is 1. 4 4s are 16. 16 is 7, right? Oh ho ho. Oops. What do you see? So you have 2 minus 7. So can digital sum be negative? So solve this conundrum, and do let me know the answer in the comment section. Just don't tell me the answer. I won't be impressed. You can just do it on the calculator and tell me the answer. But no, you are supposed to tell me the way out. Okay, how you did it. Okay, and if you tell me the correct way, you will receive a heart from me. Okay, this is the summary for today's class. It will be available there on the website too, or you can just take a screenshot once I move off screen. Also, I want to bring to your notice that don't be over excited about this digital maths, because it has its own limitations. Okay, digital maths, like, it cannot be applied to questions which include approximation. Okay, keep that in mind. You should not use digital maths in questions which include approximations, because for instance, like, if you have 2.98 in the language of approximation, you can just approximate it to 3, right? Approximation says that insignificant digits don't matter, but for digital math, in the language of digital math, every digit matters. Okay, so you should not apply digital math to questions which include approximation. Second thing, options should be given. Now that is a very big point. Options are not given, you are lost again. And thirdly, it's 80% efficient, because some options might not have unique digital sums. Okay, that is also a valid point. Okay, so of course you know something new, which with limitations. Okay, that's the good thing. Okay, and I think that's pretty much it for today. I'll see you soon in the next class. Till then, keep enjoying digital math, keep enjoying physics.